Very quickly, I will be talking about the periodic table. I will talk about the periodic law, talk about periodicity. I'll talk a brief about the history of the periodic table and the modern day periodic table. I will lay more emphasis on the modern periodic table. I would also be talking about how the periodic properties, how they vary across the period and down the group. I'll be talking about the blocks. How do you identify the blocks? Okay, the S block, the P block, the D block, the F block. I'll be talking about some properties of elements on the periodic table. I hope that is clear. So I want to pay attention to the end of this class so that you can understand and comprehend fully what the periodic table is. And you know what? When you understand the periodic table, chemistry becomes very, very much simplified for you. So I wanted to pay attention. So come with me. In the history of the periodic table, about 3 different periodic tables have existed in the past, but there were limitations to them, and presently we are now working with the modern day periodic table. Part of the 3, there is the Dobrynin's periodic table, okay, who spoke about the triads. Then there is the Newland's theory. The Newland's table also, he spoke in terms of atomic masses, but there were some limitations. And then we have the Mendeleev's periodic table, who also spoke about atomic masses, how elements are arranged on the periodic table in order of atomic masses, but there were some limitations. One of the limitations to Mendeleev's theory was that hydrogen, there was no specific place to position hydrogen. Okay, there was uncertainty in terms of the positioning of hydrogen. Right, and so because of such limitations, and there were also some other elements that could not be arranged in order of masses, atomic masses. So, and then came the Moseley's periodic table, which is the one we're talking about today. In 1913, that was when the Moseley's periodic table became adopted, and Moseley gave his own theory that elements are arranged on the periodic table in order of their atomic number, and that constituted the periodic law. So I'm going to start. So we're talking about the Moseley's modern periodic table. Now this Moseley's modern periodic table. So according to this table, the first thing is the periodic law. So what is the periodic law? The periodic law states that the chemical and physical properties of elements on the periodic table are periodic functions of their atomic number. So you could be asked in your exam to define the periodic law. The law states that the chemical and physical properties of elements on the periodic table are periodic functions of their atomic number. Please emphasis on atomic number. And what is the interpretation of that, or the implication is that? So the interpretation is that elements are arranged on the periodic table based on their increasing atomic number. Increasing atomic number. So that is how elements are arranged on the periodic table. Now, before we go into the details of the periodic table, let me talk about the atomic number. What is the meaning of atomic number? Atomic number is the number of protons present in an atom of an element, and of course it is also the position of an element on the periodic table. Okay, that's atomic number. Why mass number is atomic mass, which is also called the mass number, is the sum of protons and neutrons, all right, in the nucleus, okay, in an atom of an element. All right, so that's the difference between atomic number and mass number. So the periodic clusters are elements arranged on the periodic table in order of increasing atomic number, and that atomic number is the number of protons present in an atom of an element. While atomic mass, which was what the last two, which is the Newland's periodic table and the Mendeleev periodic table, they actually arrange in order of atomic mass or the mass number, but there were limitations, and then we had to resort to the Moseley's modern periodic table. Now that you've understood that, let us now go deeper into that periodic table. We're going to draw the periodic table on the board, but before we continue, we need to understand what groups and periods are referred to. So when we talk about groups, so elements are arranged on this periodic table in groups and periods. The groups are vertical arrangements of elements, that is group, vertical, right? And it's important to know that the periodic table has 18 groups. So there are 18 groups. What's more, there are properties of members of the same group. So I said groups are vertical, so this is vertical. So there are 18 groups on the periodic table. Then members of the same group, they have the same number of elements in their, they have the same number of electrons in their outermost shell, which is what you call the valence electron. They have the same number of electrons in their outermost shell, and that's what you call the valence electron. That's number one. Number two, they have similar chemical properties, and because of that, they take part in similar chemical reaction. So I said members of the group, members have same number of electrons in their outermost shell. That is also called valency. So you can call that valency. They have the same valency. And of course, members have similar chemical properties, and because of that, they take part in similar chemical reactions. Now note, I'm going to give you an acronym that you will use to remember this in the exam hall, so that when you get into the exam hall, you know exactly which one is vertical, which one is horizontal. The acronym is VGC and pH. So what's the meaning of VGC and pH? Right? I want you to go to the comment section and type in VGC and pH. So what is VGC? VGC is a location in Lagos, that is Victoria Garden City. pH is a location in Rivers State, that is Port Harcourt. But what has that got to do with chemistry? All right, in chemistry, so VGC means in chemistry the groups are vertical. In chemistry, that's VGC. pH, which is Port Harcourt, simply means periods are horizontal. Periods are horizontal, groups are vertical in chemistry. So you can always use that to remember. That is number one. Number two, what is the meaning of vertical? What is the meaning of horizontal? Now, when you stand like this and you raise your two hands up, this, okay, what shape or what letter, what alphabet is my hand showing? That is the V. This is V. So if I stand like this is V. So this is vertical. But when I drop my hand and make it straight like this is horizontal. So this is horizontal, but when my hands are up, that is vertical. So meaning when I stand erect, so when you are trying to recall which is vertical, standing straight is vertical, and then stretching your hand to the sides, that is horizontal. The meaning of that is these are the vertical arrangement of elements, these are the horizontal arrangement of elements. And you remember I told you that there are 18 groups. So if we are going to label it, this is group 1, this is group 2. Now, I left a space in between this group 2 because that is where you have the transition metals, the D block elements, the transition metals. So this table, we know, because of what we want to do today, I wouldn't be going for the full table, okay? Once it's time to talk about the transition, I'll scoop this out of the complete and I'll talk about it. But for you to have a good understanding, let's begin with the basic elements on the periodic table for a start. So this is group 1, group 2. So here there are 10 groups. There's this D block, all right? This D block, there are 10 groups there. So this is group 1 to 2. So group 3 to group 12. Group 3 to group 12, they are the D block. The group 3 to group 12, 10, 11, 12. All right, group 3 to group 12, they are the transition elements. There are 10 groups there. All right, so if I'm going to draw, there will be 10 groups here. And then after group 12, then you now have group 13, 10, 11, 12, 13. Group 14, 10, IV. This is group 14. Group 15. This 16, so there's a mistake here. V1, 16, right? Then 15, 16, 17, 15, 16, 17, 18. 18. So take note of that. You can also write these in numbers, but it's more preferable to write the groups, to label them in Roman numerals, and then you can now label the periods in using your normal numbering. Okay, so these are the D block. Now this is going to be my period 1, my period 2, 3, 4, 5, 6, 7. So take note of this. There are 18 groups and 7 periods on the periodic table. 7 periods, 18 groups. Right. So these 7 periods, so elements that are arranged like this, they are the periods. So in period 1, we have hydrogen here, and we have helium here, lithium, beryllium. I'll skip all of this. That's neon, sodium, calcium. Okay, so those are the first 20 elements. There are other elements that make up these different groups. For example, in your group 1, there are other 3 elements with the acronym RCF. Or is RCF? Rubidium. Rubidium. Your C is your calcium, not calcium. This is calcium here. Calcium. All right. CS, calcium. And you have francium. FR, francium. So those are the elements in the group 1 of the periodic table. They are the elements in the group 1. For the group 2, for example, SBR. That's the acronym. SBR. What is SBR? Strontium, barium, and radium. SBR. Okay, and then you have them like that. Now, but because of what we're about to do today, all right, I will just talk about a few of them. So this hydrogen, this is, if I'm going to write the configuration, electronic configuration, helium is 2, then lithium is number 3. So before I do the configuration, this is 1 atomic number, number 2. Let me label the atomic number 3, 4, number 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The first 20 elements are going to guide us in this conversation today. I've written the atomic numbers. Now let me now write the configuration, because I'm going to use it to show you a few stuff. So this is the configuration 1, this is 2. For even though there are 3 electrons here, but the configuration is 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Then instead of 11, this is 2, 8, 1, 2, 8, 2, 2, 8, 3, 2, 8, 4, 2, 8, 5, 2, 8, 6, 2, 8, 7, 2, 8, 8, and 2, 8, 8, 1, 2, 8, 8, 2. 2, 8, 8, 2. Let me stop at that point. Now, if you look at all the elements on this side, they are ending with 1, 1, 1, 1 in their outermost shell. The same goes for every one of them. So they have 1 in their outermost shell. All right. So those are group 1 elements. All these elements, they end, like I said elements have same number of electrons in their outermost shell. So beryllium, magnesium, calcium, strontium, they all have 2 electrons in their outermost shell. If you come to group 3, they all have 3 in the outermost shell. Group 4, 4, 4, 5, 5, 6, 6, 7, 7, and they have 8 in their outermost shell. So those are the groups. Now let's talk about period. So we're going to define periods, and then I will reduce this periodic table. I'll reduce it to the first 20 elements, and we're going to use it to explain further. Now the next thing we talk about is the period. What is the period? What are periods? Periods are horizontal arrangement. You remember pH. All right, periods are horizontal arrangement. All right, so periods are horizontal arrangements of elements on the periodic table. On the periodic table, that's that. Number 2, these elements on the horizontal arrangement, what do they have in common? They actually have something in common. They have the same, look at everybody here, 2, 2, 2, 2, 2, 2 room space, or you can call that 2-bedroom flat. All right, everybody here, they have 3, 3. This is 281, 281, so 3 rooms. Everybody here, they have 4. This is the first, that's the second room, the third room, the fourth room. Everybody on this lane, they have 4-bedroom flats. Let me put it in that manner so you can easily remember. So in period 1, they just have just one room. So 1 room apartment. These guys, they have 2 rooms each. All right, they are just managing 2 rooms each. These guys, they are big boys. So they have 3 rooms each of them, 3-bedroom flats. These guys are living larger than life. They are the biggest boys in the first 20 elements. So they have 4 rooms, each of them. So what has the rooms got to do with chemistry? Members of the same period, they have the same number of atomic shell. Atomic shell. Atomic shell means or better still, the same number of electronic shell rather. Electronic shell. Electronic shell means the shells where electrons are found. All right. You know, electrons are found on the shell, so they have the same number of electron shells. You can either say electron shells or shells. So the members have same number of electron shells or orbitals, same number of shells, the same number of shells or orbitals. So, and what else? What's more, if you look at the valency, the valence number of electrons here is 1, 2. If you come here, 3, 4, 5, 6. Valence number of electrons here, 1, 2. Valence means in the outermost shell, next 3, 4. So their atomic, their valence electrons increases across the period. So valence electrons of members increase across the period. And of course, lastly, their atomic number. The atomic number of lithium is 3, that of beryllium is 4, boron is 5, carbon is 6. Atomic number of sodium is 11, magnesium 12, aluminum 13. So the atomic number also increases across the period. So the atomic number of members of the same period increases across the period. So in your exam, you could be asked to write what are the similarities, what do members of the same period, what do they have in common? This is it. Members of the same group, what do they have in common? We've spoken about that earlier. So now we've spoken about periods and we've spoken about groups. So let's go back to what we have here. So let me now talk about the blocks. The block. Okay, so group 1 and 2 are the S block. S block refers to group 1 and 2. So in terms of blocks, group 1 and 2, they are the what? S block. Now, group 13 to group 18 are the P block. Group 13 to group 18. They are the what? P block. Now, it was an error earlier. So group 13 to 18, they are the P block. Then the group 3 to 12, group 3 to 10, 11, 12, they are the D block, which are also called the transition metals, the D block. And then you now have the last block, which is the F block, which are at the base, somewhere around here at the base, when you go towards the the last two periods, period 6 and period 7. Okay, if you look at the period 6 and period 7, you will see the actinides and the lanthanides. Those are the F block. Those are the F block. So the actinides and lanthanides. So actinides and lanthanides, they are the F block, and they are within the last two period, all right, sharing their boundaries with the D block actually, but they are the last two periods. Okay, so that's group, that is that. Next, let's move forward. Group 1 elements are called the alkali metals. Example of alkali metals are your sodium, potassium, rubidium, etc., rubidium, francium, caesium. They are all in group 1. They are alkali metals. Then we have the group 2 elements are called alkali earth metals. Alkali earth metals, e.g. of alkali earth metals, magnesium, calcium, etc. You have strontium, you have barium, you have rubidium. Radium rather. Yes, strontium, barium, radium. Now, let's talk about the group 17. 15, 16, 17. The group 17 are called halogen. They are the halogen. Examples of halogen, that is group 17. You have fluorine, chlorine, you have bromine, you have iodine. All right, those are examples of the group 17. All right, and then you have the group 18. Group 18 elements they are called the noble gases. Noble gases or rare or inert gases. Examples are neon, helium, argon, etc. Neon, argon, helium, etc. Now, inert means inactive. So these gases are very, very inactive. They are not very active, unlike the group 7 elements, which are radicals, which are very, very reactive. In fact, the most reactive element is fluorine. It's very, very reactive, right? And that group is the most reactive group as well amongst the non-metals. While in terms of reactivity for the metals, the group 1, they are most reactive. So the next thing we will talk about, we'll be talking about periodicity and the periodic properties, how they increase and decrease across the period and down the group. Let's talk about the periodic properties. So when we say periodicity, you could be asked to define it. Periodicity is simply the variation or changes in periodic properties across the period and down the group. So when you say periodicity, it means how do the properties, the periodic properties, how do they change across the period? How do they change down the group? That's the meaning of periodicity. Now let's talk about these periodic properties one after the other. Let's start with the metallic property or metallic ability property. When we say metallic ability, metallic properties, we are talking about ability to conduct electricity. That's conductivity, electrical and thermal conductivity. So in terms of this, you have electrical and thermal conductivity. Right. This property is actually, you have them amongst the metals, you do not have them amongst the non-metals. So ability to conduct electricity, it increases across this period among the metals. So aluminium has the ability to conduct electricity and conduct heat more than sodium. That is why you've heard about aluminium pots, you've heard about aluminium wire, all right? But you have never heard about sodium pot or potassium pot or calcium pot Why? Because even though they are metals, but their ability to conduct heat is not as high. If you use a sodium pot to cook, that pot is going to break. The temperature will bring about expansion. All right, and because it does not have ability to resist, it's going to break. But aluminum can actually resist it. So that property increases across the period among the non-metals, while it is non-existent in the non-metals, right? The next property I'll talk about is the melting and boiling point. Now, before I proceed, let me say this. Group 1 to this group 13, they are all metals. Group 1 to 13 are metals. And you remember between group 2 and group 13, which is group 3 to 12, they are transition metals, so they are still metals as well. So this D block, these are transition metals. Transition metals, so they are still metals. So this group 1 to 13, they are metals. This group 14, they are metalloids. While the group 15 to 18, they are non-metals. These are metals, okay? That's why the group 1 are alkali metals. Alkali earth metals, so they are metals. And of course, transition metals, because they are metals as well. While the group 4 or group 14, group 14, they are the metalloids. What are metalloids? Metalloids have the ability to act as metals and non-metals at some point. So they have the properties, they have some properties of metals, some properties of non-metals. For example, if you look at carbon, there are two major allotropes of carbon, diamond and graphite. One of it has the ability to conduct heat and electricity. And which is that? All right, it is graphite. Graphite has the ability to conduct heat and electricity. Diamond does not have the ability, even though diamond is the hardest substance ever known. Right, the hardest substance known, but it does not conduct electricity. Why? It is too hard. The particles, all right, of diamond are very, very closely packed together. So there are no free particles, free electrons moving around. They are all packed together, and because of the very high force of attraction. So that is why diamond is not a conductor. So carbon, a part of it acts as metal, another part of it acts as a non-metal. So that's why they are metalloids. Okay. All right. Melting and boiling point. For melting and boiling point, of course, amongst the solids, they are very high melting and boiling point, or melting point. Metals melt, solid will melt, liquid will boil. So this property, melting and boiling point, it decreases. Now, among the metals, it's increasing because these guys are more, they are harder, all right, compared to these guys. So amongst the metals, so increases across the period among metals, but decreases among non-metals. All right, so those are the next set of properties I'll be talking about. I'll talk about ionization energy, which is the same thing as ionization potential. So what is the meaning of ionization potential? Ionization potential is the energy required to remove an electron from the outermost shell of an element in its gaseous state. So let's define it. Ionization potential, it is the energy required to remove an electron from the outermost shell of an element in its gaseous state. Right? This ionization potential is the energy required to remove an electron from the outermost shell of an element in the gaseous state. So here, very low energies. Now note, all these elements, they want to attain octet valency. Octet valency means they want to have 8 electrons in their outermost shell. So for them to be able to have 8 electrons in the outermost shell, they will either give out electron or borrow electron. So these guys, which is easier, this guy potassium, for example, it has 1 electron in the outermost shell. Which is easier? It needs 7 to have 8. Is it going to kidnap 7 or it will give away 1? When I say kidnap, the child of a goat is called a kid, right? So if somebody goes into the street and the person begins to kidnap children of goats, all right, babies of goats, before it gets to number 7, what will happen? He could be arrested and then they could beat him to stupor, right? So it's very dangerous to kidnap 7. So it's easier for this guy to give away 1. It's easier for sodium to give away 1. Therefore, elements, these metals, they take part in reaction by donating electrons. So this guy will give away 1 and it will have 8 in the outermost shell. But when you come here to non-metals, this guy has 7 in the outermost shell. Needs 1, just 1 to have 8 octet valency. So what is it going to do? It has 2 options. Is it going to throw away 7 German Shepherd puppies? You know how expensive German Shepherd puppy is. If you have 7 of them, maybe you have a German Shepherd at home that has 7 puppies, and the dog went to jog around the streets one of the weekends and came back, went with 7 puppies and came back with 2, thrown away 5. Would you be happy? You'll be very mad at the dog. So it's easier for this to do corporate begging for 1 than to throw away 7. So that corporate begging is what you call, it becomes negatively charged because it's borrowing. Borrowing is negative action. So borrowers are negative, givers are positive. So metals form positive ion. So sodium, potassium, they form positive ion, while the non-metals, they form negative ion. They would accept or borrow electrons. While the noble gases, this group 18, they will not take part in chemical reactions at all. They neither give out nor accept. Now, so let's come back to ionization energy. How does it vary across the period and down the group? So here, little energy is required to remove electron here, but very high energy is required here. That means that ability is increasing across the period. Therefore, ionization energy, it increases across the period. It increases across the period, decreases down the group, decreases down the group. So it increases across the period, it decreases down the group. Talking about ionization energy, the next one I'll talk about is electron affinity. What is electron affinity? It is the energy that is lost when an element accepts electron. It is the energy lost when an element gains electron. It is also called the love for electron. Affinity means love. It is love of electron. So let me ask you, which of these has more love for electron? Is it these guys here or these guys here? For these guys here, they are ready to give out this 1 electron and have it in the outermost shell. These guys, they have 2, so it's easier to give out 2 than to kidnap 6. Yeah, it's easier for them to give out. But here, they are very ferocious kidnappers. Sorry, I'm using that. Just trying to make that easier for you to comprehend. These guys, they need dearly just 1. So if you want to come and take from them, if you don't hold the electron you are having with you, if you don't hold it tightly, they will collect it from you. So they are very ferocious. Okay, so and that's why they are very reactive, radicals. So they have the highest love for electron, while this very low love for electron. Therefore, electron affinity, it increases because it's the highest here. So it increases across the period and decrease down the group. Next, let's talk about electronegativity. Electronegativity is the readiness of an element to become negatively charged by losing electron or by gaining electron? What will make an element to become negatively charged? It is by gaining electron. By gaining electron, by accepting, by borrowing. Borrowers are negative, givers are positive. So electronegativity is the readiness of an element to become negatively charged by accepting or borrowing. You can say accepting or gaining or borrowing, to make it easier, borrowing electron. So who are the guys that borrow? These guys are borrowers, these guys that are givers. Therefore, it increases across the period and decreases down the group. So what does that mean to you? There are three properties that have the same periodicity across the period and down the group, which I have quickly spelled out. And I'm giving you another acronym for the three of them, EIA. What is EIA? EIA means E is electronegativity, I is ionization energy, A is affinity, electron affinity. So these three, they have the same periodicity, meaning the three of them increase across the period and they decrease down the group. Electronegativity, ionization energy, electron affinity increases across the period and they decrease down the group. Now let's look at another, the next three again. I'm going to give you another three that have similar periodicity. Electropositivity. Electropositivity is the readiness of an element to become positively charged by, is it by losing or by gaining? By giving out. Givers are positive. So when you give out, you lose it. By losing or giving out electrons. Now let me give you another acronym here. Oil rig. What is the meaning of oil rig? Oil rig is oxidation is loss, reduction is gain. So when oxidation, which is loss of electron, is also when the oxidation number increases. All right, while reduction is when your oxidation number reduces. It is the gaining of electron that will make your oxidation number to reduce. And so when from positive, if you now reduce to negative, that means you have gained electron, but you have been reduced. And that is electronegativity. Readiness to become negatively charged by gaining electron. All right? While electropositivity is readiness to become positively charged by losing electron. Losing electron. Now this property is It is higher here, very low here. These guys are more ready to lose electron. This guy is ready to lose electron and become positively charged. So it's easier for it to have 288 than to kidnap 7. So it's ready to give out 1. So it decreases. So if it's higher here and very low there, there is decreasing across the period. It decreases across the period and increase down the group. Now note, there's something I didn't mention earlier. Any property that increases across the period, the reverse will happen down the group. So whatever is happening across the period, the opposite happens down the group. When a property is increasing down the group, it will decrease across the period. When a property increases across the period, it will decrease down the group. All right? So these things are very easy. You don't need to, it doesn't have to give you headache. All right? For example, electronegativity is increasing across the period for electronegativity, for ionization energy, for electron affinity. They are all increasing across the period and they are decreasing down the group. While for electropositivity, it is decreasing across the period and increasing down the group. Now, the next to electropositivity is atomic radius. And the last one is ionic radius. Ionic radius. So what's the difference between the two of them? Radius is the distance from the center of the circle to any part of the circumference of that circle. Right? So when you have an atom, the distance from inside the nucleus to the outermost shell, the distance between the nucleus and the outermost shell, that is the atomic radius. So the difference between atomic and ionic radius is that is atom and ion. So a neutral atom does not have a charge. It has not given out electron. It has not accepted electron. While ions, ionic radius, these are ions. Ions have either lost electron or accepted electron. So for example, Na and Na plus. Na plus is an ion, is a positive ion. This is an atom of sodium, right? But whatever the case may be, both of them, they have the same periodicity. And let me give you that periodicity. If you recall, I told you period 4, they have 4 shells. Period 1, they have 1 shell. So meaning 1 shell in period 1, 2 shells in period 2, 3 shells in period 3, 4 shells in period 4. As they are coming down the group, the number of shells is increasing. So if an element has just 1 shell and then another one has 1, 2, 3, 4 shells, who amongst them will have a longer radius? It's the guy with more shells. The meaning of that is that atomic radius and ionic radius increases down the group. As the number of shells are increasing, the atomic radius and the ionic radius are increasing as well, while they are decreasing across the period. Now that is clear. So the meaning of that is atomic radius and ionic radius increase down the group and decrease across the period. Now the same thing applies to ionic radius. It increases down the group and decreases across the period. Full stop. So these are 3 other, which is electropositivity, atomic radius, ionic radius. There are 3 other properties. They also have similar periodicity, which is what? They are increasing down the group and decreasing across the period. And I hope that simplifies periodicity for you. So you can pause this video, go over it again. If there is any of the acronyms that resonated with you, that excites you the most, go to the comment section and type in that acronym. And if you've gotten value from this video, you can type value in the comment section. Remember to share this video with your friends, drop your comments, like it, and if you have not subscribed to our channel, what are you waiting for? Go hit the subscribe button right now, and thank you for being a part of today's class. See you in the next class. Wish you success in your exams. Bye for now.